There. Hi, good morning, everybody. Now, I promised today I'd go through the Alkenes and Alkynes problem set, and I will. Dr. White keeps his promises. And what I'd like to do first, though, is I'd like to finish up two quick reactions on the aromatic, and that way this weekend you'll be able to work on those on the aromatic problem set. Now, I don't know if I told you this, but my classroom is a democratic dictatorship. I'll ask for your advice and then I decide. But anyways, how many would like to do the aromatic problem set on Monday? Raise your hands. How many would want to do it on Wednesday? Raise your hands. How many people don't want to raise your hands? Raise your hand. All right, I'll do it on Monday. All right, coming attractions next week. Next Monday, I'll go through the aromatic problem set, and I'll finish up a little thing on the aromatic compounds that I won't get to today. And probably won't be on the test, but it's good stuff to know about. And then Tuesday will be the world famous review for test number 1. And students have found it very useful, so let me know if you found it very useful. And then on Wednesday, I'll start on alcohols, unless there are any questions on the aromatic compounds or anything else for test number 1. And so please be, those of you who like to print out the notes next week, I will start alcohols. That will not be on test number 1. I've already talked about test number 1. But just a public service announcement from the management meeting a week from today will be test number 1. Information has been posted on Blackboard as an announcement and has also been sent to you as an email. All right, let's finish up the reactions of aromatic compounds. And the next reaction, I think I mentioned, but I'll go through it right now. If you stake a benzene ring, react with sulfur trioxide and sulfuric acid. This forms an electrophile, electronegative, or electron-phile-loving intermediate that sees the pi electrons on the benzene ring. Remember, all reactions are substitution reactions. You change one or replace or substitute one of the hydrogens on the benzene ring with a sulfonic acid group, and that's the only reaction I can ask you on a test. As I said yesterday, I will be not teaching you directors, though you will learn about it in the lab. But as you know, I don't put questions on the test from the lab in the lecture. So that's the only reaction. There it is. I'll teach you later on that this group can be further modified and something else put on the benzene ring, and that's the basis for all your detergents. All the detergents, and there are a few new ones now that are based on old technology, which are not really new, but coming back as new. But any of the major brands use a molecule that cleans your clothes based on this reaction and another reaction. All right. Let's look at the next reaction. I haven't done it yet because I haven't covered any, but for many decades, it hasn't been done for a long time now, but for many decades, if you discovered a really important general reaction that was widely used and very important, it was named after you. And if more than one person worked on it, sometimes more than one name. And this is called the Friedel-Crafts alkylation, discovered by the two English organic chemists, Friedel and Crafts. And this is a very important reaction. What makes it important? You make a carbon-carbon single bond. It's very rare in organic chemistry to make a carbon-carbon single bond. It's rare, it's beautiful, it's important, and most of all, it's fun. And you can do some serious good when you can make carbon-carbon single bonds. Of all the hundreds of general reactions I know involving functional groups, I only know about 15 where you can make a carbon-carbon single bond. It's very rare, and this is one of them. And let's look at real fast alkylation. Alkylation means you put an R group and alkyl group on a benzene ring. And this is the other reaction that helps make molecules that are used for your detergent and a lot of other things. So if you wonder, why am I learning this? Well, if you like clean clothes, this is an important reaction. Now, what you do is you take an aromatic compound. For this class, it will be benzene, react it with an alkyl halide. Now, R means anything with carbon and hydrogen. And X, for this one, is usually chlorine and rarely, but sometimes bromine. That's mostly economical reasons. And what happens is you form a carbon-carbon single bond between the carbon on the benzene ring to the carbon on the R group. Which carbon? The carbon that has the halogen on it is the carbon bonded to the benzene ring. So let's take a look at one. Now sometimes if R is large, I'm not going to put it above the arrow. I can put it like this. And how do you do this reaction? How do you determine what is the product or products of this reaction? On the test number 1, I'd have a question, give the organic product or products to the following, 3 points each, and this could be one. Well, we look at what's different. Ooh, benzene ring. Now I'm reacting with another organic molecule. What's different with that? What's not carbon or hydrogen? Halogen on the carbon. This is an alkyl halide. This is your R group. Did you break carbon-carbon single bonds? No. So you get, when you react this plus the alkyl halide and aluminum tri, in this case chloride, you get a benzene ring. Well, I can do that. What's my R group? 3 carbons. Now the important part is, which of those 3 carbons is the carbon with the halogen? And the answer is the N one. That's the carbon that the benzene ring is bonded to. And I've now done something really good. I made a carbon-carbon single bond, and if you notice, I'm happy. Even on the board, I'm happy. And for your own fun and enjoyment on this sunny but cold morning, why don't you try this? What would be the organic product? Okay. Yes.
What happens to the last,
What about it?
to the chloride on the,
Oh, what happens to the rest of that?
yeah, because you would
All right.
add
Oh, hold on,
C3.
hold on. Remember, organic chemists are very biased when it comes to inorganic stuff. We just say, forget about it. And I just did. What happens is, you'll get the H from here and the Cl here, and you'll get HCl. I'm putting in brackets, here I have HX, because on my test, I'll ask you, give the organic product or product. Now, if it helps you putting HCl down, please do. If you don't care, don't, because if you have it there or not, I won't grade it, only based on what's the organic. You'll see throughout the semester we do that, I'll do that, organic chemists do that with things like water and other inorganic stuff. case you came in late, I'll have the signing sheet up here. All right, looks like everybody's done. Let's go ahead and do this. All right, how do we determine what's the, clearly listen, the organic product or products of this reaction? Well, what's different? Well, I've got a benzene ring. That's different. What am I reacting with? What's different here that's not carbon or, ooh, a halogen? And it's on carbons. I can call that RS. I've got aluminum trihalide, in this case chloride. What happens? Friedel-Crafts alkylation. I use the name to honor the two chemists who discovered this. Remember, the bond from the benzene ring to the R group is to the carbon on the R group that has the halogen. So if I look at my general reaction, first of all, I'm going to have my benzene ring. And then it doesn't matter which carbon, but mostly you're going to put it on the top. What's my R group? 4 carbons. Do you break carbon-carbon single bonds? No. And which carbon has the halogen? The second one. And that's going to be the one bonded to the benzene ring. And you form this molecule. And that's how you do Friedel-Crafts alkylation. Now, as I said the other day, on test number 1, I'll have only one synthesis problem, but it can be for any of the general reactions I've talked about in class. And if I were to put on a test the synthesis problem, synthesis means to make, the question would be, what's the product or products, what's the starting materials or reactants? On my test I use starting materials because that's what we use in industry terminology to make that product. And I'll help you out, don't tell anybody I'm being nice, but I'll put a question mark for each starting material. So it tells you need 2 starting materials. So how do you do this? Well, you look at the product and say, what's different? Oh, I've got a benzene ring. Oh, but I've got carbons on an alkyl group. I'm reacting something with aluminum trihalide, or X here probably could be chlorine or bromine. And what do I react to make that? Hopefully you'll learn the general reaction. Benzene ring plus an alkyl halide gives me my product. And therefore, what are the question marks? Well, one of them is a benzene ring. And the other is an alkyl halide. What's my R group? The carbon's there. Do you break carbon-carbon single bonds in a reaction? No. So this R should have 4 carbons. Remember, this is part of the semester, you have to know how to count up to 10. And now, which carbon has the halogen and what is it? It's bromine. And which carbon is bonded to the benzene ring? The N1. Therefore, the N carbon here will have the halogen. In this case, it's bromine. And that's how you do it. And by the way, this is the fun part, so I'm going to share some of the fun. the question would be 6 points, 3 points each. What would be the starting materials for the following reaction? Looks like everybody's done, so let's take a look at this. How do you do this? And before, I need to see an ID though. All right, let's go do this. But before I do this, think about how much you've learned in a short period of time. Think about what I asked you to do. I said, find the starting materials for this reaction. I just taught you a general reaction. If you look at this 6 weeks ago, if I put this on the board, what would you see? Lines and letters of the alphabet and numbers. What are you seeing now? Molecules. What are you doing? Very sophisticated organic chemistry. Doesn't that feel good? It should. All right, let's take a look at this. What's different? Benzene ring. It's got carbons on it. Therefore, I have a benzene ring with an R group. What am I reacting to make that? Aluminum trihalide. What's my halogen? Well, it can be, in this case, chlorine or bromine. What do I start with to make that? You start with benzene plus an alkyl halide. What's my R group? Carbon and hydrogens. This is R. And therefore, what are my question marks? One of them, and it doesn't matter which you put first or second, is the benzene ring. Then what's my R group? 2 carbons. What's my halogen? Chlorine. And that's how you do it. You're doing synthesis, the fun part of organic chemistry. Yes, Lisa. Look out, I'm learning names, so I'm getting dangerous.
Does it matter if you write the CH2 before it doesn't, right, because it flips?
No, because remember when you did the models lab last week, cyclohexane or propane or ethane, you could move them around just like I'm doing right hand. So no. And if you're ever doing problems before the test, and if you're not sure, ask me like you just did. And what you're saying is, what if you put the CH3 on the other side? And also, in this answer, I could have just as easily written it this way. Either one is correct. Here's my left hand. Oh, look, something different. No. Because molecules, even though we write them on a whiteboard or paper and you think they're stuck there, they're not. Good question. Thank you. All right. Let's go, it has some more in the chapter, but let's first, this gives you enough information to do the problem sets for aromatic compounds for Monday, as you all agreed to do it. So work on it over the weekend. For test number 1, the best way to study for it is do the practice problems. If you can do the practice problems correctly, you will do quite well on test number 1. You'll learn why I call them practice problems. All right, let's go through the Alkenes and Alkynes practice problem set. In case you forgot, I'll do 1 page at a time. Also, since I haven't had a miracle happen to my ear since we last met, the hardest thing for me to hear or understand is letters of the alphabet. So say them loud, but you don't have to scream them so they hear them down the hall, but this won't hear it. All right, page 1. First question, give the IUPAC name for the following molecules. And let's look at A, B, C, or D. Does anybody have a question? A, B, C, or D? I have a taker here.
For the letter D,
I can. Next question.
I'm
just kidding. Let's do it. Did you say E?
D.
What?
D.
I told you I had. All right, let me back up. C. All right.
No. D.
No,
D.
D is in dog.
All right.
D is dog.
I'm going to hand out alphabet cards. D like in dog.
Yes.
Well, you found out Dr. White wasn't lying to you. All right, let's look at D. First thing you have to do is say what's different. What's not carbon? Carbon single bond, double bond. How many carbons in the longest chain with the double bond? 1, 2, 3, 4, 5. Remember, you have to have both carbons in double bond. 1, 2, 3, 4, 5. And that's pentane, double bond. Drop the A and E ending, put in E ending. Pentene. What's the lead carbon? Let me try something. Can you people see this, or is the glare bad? Is the glare bad on this right now? A couple of what? How many can't see this well? All right. This way, I won't get in trouble with the school because I'm not supposed to write on the screen, and therefore, as soon as I say 2-pentene, that's spoken for. Okay? Next, what do I have? Ooh, a methyl group. But before that, you learned about cis-trans isomerism, and what was one of the things I told you? When you have two atoms or groups that are the same on one of the carbons of the double bond, you cannot have cis or trans. So let's look at this carbon. Even though it's part of the chain, we're now looking at cis or trans. What do I have that are the same? Two methyl groups. They're not considered in the name, but just CH3 groups. Therefore, I can say, oh look, this hydrogen is cis to the methyl group. This hydrogen is trans to methyl group. It can't be both at the same time, therefore it's neither. And when you have two atoms, like two hydrogens, or two groups like this on the same carbon, you no longer put down cis or trans. So, I now have 2-pentene. I can continue to say what's left over, methyl group. What carbon is it on? Well, this was 1, this was 2. Why do I go that way? Because if I go this way, 1, 2, 3, you number from the ends that give the carbon atoms the lowest number. This would be 2, this would be 3. Now you have to use your high-level math skills in my class. What's the lowest number? Hopefully all pick it. And that's how you do it.
Thank you.
You're welcome. I'm in the neighborhood. Let's do C, only because I like to do C, and I'll do even D also. All right. Question is, what's the IUPAC name? What do you see different? Double bond. How many carbons in the longest chain? 1, 2, 3, 4, 5. Pentane. Drop the A and E ending. Pentene. Put E and E. It's carbon 2. And now, if I put my plane or my hand or on the test, the pencil or pen, you can see on each atom of the double bond, each carbon atom, I have an atom or the same atom or group, hydrogens, and notice they're below my hand, that's cis. If they were opposite side, it would be trans. So that's why it's cis trans 2-pentene. If we go to B, what do we have that's different? Question, Randy.
I'm still confused as to
I
how.
talk louder.
Sorry, I'm still confused as to.
Do you want me to do it again?
Yes, where you got the
All right.
2 from for 2-pentene.
All right.
Thank you.
The question is, where is the double bond? IUPAC names you never have to guess. It could be between these two carbons, or it could be between these two, or between these two. So how do you determine where is it? You start always from the end of the chains, and you number. And you number in such a way that the lead carbon of the double bond gets the lowest number. So what's the end of the chain? This carbon or this carbon? If I make this 1, this becomes 2. And that's how you get to 2.
Because otherwise it would be 3.
It would what?
Because if we went from the other side, it would be 3
All right,
and
let's
3
do
is
it
bigger
this
than
way.
2.
The lead carbon, 1, 2, 3.
And we're
Now,
looking,
which one of those numbers is smaller?
2.
Hopefully you pick 2, and therefore this is the way we number.
okay.
And it's always true for acyclic compounds, in other words, those in a chain, not a ring.
Okay.
You always start from one or the other ends to give the key functional group carbon, in this case the lead double bond carbon, the lowest number.
Okay. thank
So
you.
now you know and you won't get that wrong in the test, and the rest of you won't either. All right, let's go to the ring. On a ring, we don't use a number. First of all, I have a double bond. How many carbons in the ring? 6. It's hexane. Double bond becomes hexene. It's a ring. It becomes cyclohexene. Oh, quick, public service announcement from the manager, me. Test number 1, students forget to put the word cyclo for a ring, and I'll mark it wrong. Make sure if you have a ring, you have the prefix cyclo. So this is cyclohexene, because if it's the only functional group, which it is, one of the carbons has to be 1, the other has to be 2. We don't put that down. And then you number in such a way that the alpha groups get the lowest numbers, and the only way you can do that is that's 1, 2, 3. Oh look, your old friend the methyl group on carbon 1, and ethyl group on carbon 3, 3 ethyl, 1 methyl, cyclohexane. All right, question 2. Draw the condensed structure for the following. I use that names of molecules. And here, these are 2 types of nomenclature of naming questions I can put on test number 1 or the other test too. Anybody have A, B, C, or D? Ones, twice. Can you do C? Of course I can. And if we look at C, what do we have? 5,6-dimethyl trans 3-octene. What do? You start from the right, move this way. ENEND, double bond. If that were ANE, octane, 8 carbons. And where is the double bond? The first carbon of the double bond is 3. So if I do this is 1, 2. Now since I have trans, I have to show the bond angles. Trans means hydrogen's usually opposite sides. Carbon, 1, 2, number 3, hydrogen going down here, hydrogen going, the rest of the 8 carbons go that way. Double bond, that's trans. And then methyl, CH3, diamines 2, trimines 3. Diamines are 2 methyl groups, where are they? Carbons 5 and 6, and we're done. Now, on the problem set, you'll see this. You'll see this a lot of times on the internet where I don't do it in class. Oh, look out. The dreaded hydrogen virus stole the hydrogen from that carbon. I gotta get my computer at home and clean out from that. Anyways, I'll do this way also. On all of organic chemistry at my level, we don't write carbons like this, like isopropyl or T-butyl. We use this line method also for alkyl groups. And every bend in the line is a carbon, 1, 2, 3, middle carbon there. Every end in the line is a carbon, carbon intersection, end of the line, T-butyl group. You can do that if you want. I would recommend the other way, but I do put those down for rings. Yeah.
For B and C, would we lose points if we didn't show the angles so long as the hydrogens are on the right sides?
All right, in your case, I would accept it. What your colleague just asked is in a double bond, I have cis-2-butene. If you showed it this way, I'd accept it. However, if you show it this way, I'd probably give you 0 points because you're not showing me what cis or trans is. So, but the safe way is to do it that way. But I will accept it so you now have witnesses, I said that. And obviously trans, you have one of these up. All right, any other questions on A, B, C, or D? Going once, twice? All right, let's move on to the reactions. Now, if you remember on the email and the announcement, I think it was 47 points will be reaction. And what kind of question? All but one question will be, give the organic product or products, except for combustion, give the products. And let's look at A or B. Anybody want A or B? Which one? A?
A?
A. That's what I said. All right, let's take a look. How do you know what to do? When you look at this reaction, you'll see this, 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 and it'll be blank. Now, how do you know what to put down in tests or in real life? How do you know what the product will be? Well, you look at what's different. Double bond. What am I reacting with? Hydrogen and the catalyst. Notice on each one of these I try and put the general reaction. For a couple I give you, you break the pi bond and each carbon of the double bond gets a hydrogen. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4 across, 1, 2, 3, 4 across. I add 2 hydrogens. Another way of writing that, which you might find easier, would be, and totally acceptable. Those are 2 carbons, double bond, break the pi bond. Each one gets a hydrogen, and now I can put in the hydrogens because I know there are 4 bonds to carbon. Does this look like it's coming right at you in 3D? Remember, test number 1, and 2, 3, 4, 5 in the ACS final. Always check your answers that there's only 4 bonds to carbon. If you don't have 4 bonds to carbon, you have 3 or 5, or even 6 I saw once, it's going to be wrong every time. And I'll bet all the money and my credit cards in my wallet on that. And my credit cards are not maxed out. I pay my monthly thing whatever I owe every month. All right. Let's go to the next set. How are we doing on time? Good. If you notice, I tried to give you a couple examples for each general reaction. And if we look at C or D, I'm going to do D because I'm in the mood for it. And if anybody wants me to go back and do C, I'll be more than happy to. Question is, if you react this with this, what is the organic product or products? Look at what's different. Double bond. Remember, what's not a carbon-carbon single bond or carbon-hydrogen bond, or carbon or hydrogen atom. And therefore, double bond, what am I reacting with? Bromine gas, Br2. What's the general reaction? Notice I have up here, between the 2 examples that use this, double bond, halogen, break the pi bond, each carbon gets a halogen. I didn't put down there, X could be fluorine, chlorine, bromine, or iodine. And do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5, 6 across, 2, 4, 6 across my 2 methyl groups. Here are the 2 carbons with the dot in and a double bond, which are these 2 carbons. You break the pi bond, each one gets a halogen. One of the things I've been secretly doing in class and on my problem set is inoculating you against the chemistry instructor's favorite trick on the test. That is, put a big scary molecule, and if you don't know the general reaction, you're lost. You shouldn't be lost. All you do is look at that and say it's a double bond. All right, E and F. Anyone have? Yes?
F.
What? F?
Yes.
All right, let's go forward and do F. Now, the question is, if I react this with HI, what do I get? Good question, thank you. What's different? Double bond. What am I reacting with? HI, halogens are X, and take a double bond, react with HX, you break the pi bond, because pi bonds break like that and are fun to do. And one carbon of the double bond gets the H, the other carbon gets the halogen X. How do you know? It follows Markovnikov's rule. The carbons with the most hydrogen gets the hydrogen, the other carbon gets the halogen, or as I was taught, the richer the poor get poorer when it comes to hydrogens, and or them that hasn't gets it. Now, if we look at this, here's our double bond. And in order to apply Markovnikov's rule, we have to look at the two carbons of the double bond and say which one has more hydrogens. Oh no, they don't have them. Yes, they do. On a ring we just don't show them. How do you know how many hydrogens? 4 bonds to carbon. This carbon, how many bonds does it have? Count the lines. 1, 2, 3. 4 minus 3, hopefully there's 1. So that has 1 hydrogen. This carbon right here, how many lines or bonds do you see? 1, 2, 3, 4. 4 minus 4 is 0. Now you have to use your high-level math skills. I will not allow any electronic devices during my test, give it in a second, to determine which one of those is greater. Question?
I was with you up until we did the,
How did I get to 1 and 0?
yes,
All right. How many bonds to carbon?
4.
4. So if I count the bonds to carbon, if it doesn't add up to 4, then those are hydrogens. I'll say it again. If I count the bonds to carbon and it doesn't add up to 4, the difference is the number of hydrogens.
Oh,
So-
okay, all right.
Let's look at it again. How many bonds to that carbon? Count the lines.
3.
1 and a double bond, 2, 3. 4 minus 3
1.
tells you there's 1 hydrogen there. You don't show it, but it's there. Count the number of lines or bonds to that carbon. 4. 4 minus 4 is 0. And that's how you get that. We can do this after class or after lab. I can help you out more with this. So now this has 1 hydrogen, this has 0. And where does the hydrogen go? Here. Where does the halogen go? To the other carbon. That's Markovnikov's rule, which is this. Now, if we look at this carbon right here, it had 1. Now, it has 4 minus 2, which means it has 2 hydrogens and the other hydrogen comes in. And that's how you do it. If you're not sure, I want to finish some of this today, but see me right after lab. Or on Monday, I try and get here like I did today real early, because I had some stuff to do, but I usually get here at least a half hour early. Feel free. All right, let's do G and H. I even have an I, so G, H, or I. Does someone have a favorite? Oh, I've got 2 takers. I'll do yours then. I.
Can you do H?
I'll do both. Oh, it's 2 for 2 Thursday. Let's do, who said I first? All right. Let's look at this. What's different? Double bond. What am I reacting with? Oh, look, the hydrogen virus struck again. make that correction. Wow, I really have to change my anti-hydrogen virus software. But anyways, what are we reacting with? Acid, H plus water. Acid and water, think of water as H and OH. And acid is the catalyst, which means it's not consumed. And you break the pi bond, one carbon gets the H, the other gets the hydroxyl group OH. How do you know which? It follows Markov-Nikolson's rule. Let's look at this one. This is a hard one. How many hydrogens on this carbon? 2. How many on that one? 0. Which is the greater number? We all do 2. Break the pi bond. You break carbon-carbon single bonds? No. 1, 2, 3, 4, 5 across methyl. 1, 2, 3, 4, 5 across methyl. Oh, don't look, it doesn't have its hydrogens. But anyways, which carbon has the most hydrogens in double bond? That one, so it gets the hydrogen. The other carbon gets the hydroxyl. And that's how you do it. Now, let's do the other one that was requested, H. First, time out for the water break. If we look at that carbon, that molecule, first thing you have to ask is, what's different? Double bond. What are you reacting with? Acid and water. What happens when you react a double bond with acid and water? You break the pi bond. One carbon gets the H, the other gets the OH. Think of water as really this. How do you know which one gets what? It follows Markov-Nikolson's rule. Oh no, I don't know how many. I don't know how many hydrogens are on the carbon's double bond. So here are the 2 carbons on the ring, and now you have to know there's 4 bonds to carbon. How many bonds to that carbon? 3. 4 minus 3 means 1 hydrogen. How many bonds to that carbon? 1, 2, 3, 4. 4 minus 4 is 0. Therefore, the hydrogen will go there. The hydroxyl group will go there. You don't show the hydrogen. Here's the hydroxyl group. If you'd written the product this way, that's perfectly correct too. And that's how you do it. Does that help? All right, let's continue on to triple bonds. And triple bonds are alkynes. 2 nomenclature questions. First, give the IUPAC name for the following. How do you do that? You look for what's different. In this case, 3 lines means triple bond. And how many carbons are in the longest chain with the triple bond? Name it as an alkane. And then drop the A on the ending, put Y on the let's do C because it's right in front of me. And that was obvious. What's different? Triple bond. How many carbons in the longest chain with the triple bond? 1. Both carbons. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. 7 is heptane. Triple bond. A in the ending becomes Y in. Heptine. Next, what's the lead carbon of the triple bond starting from either end, giving it the lowest number? 1, 2, 3. So it's 3 heptine. You cannot have sister trans with a triple bond because it's linear, and therefore I continue on. Oh look, what's left over? Your old friend, the methyl group. And what carbon is it on? 2. You cannot have a triple bond in most rings, so guess what? We won't cover that. Now, how many of you on D, and don't raise your hands, but to sort of look like, yeah, I did it, put down T-butyl. Did I catch anybody? No? I got you. Anyways, what's the longest chain? 1, 2, 3, 4, 5, 6. hexane, triple bond, hexine, carbon number 3. What's left over? 2 methyl groups, and therefore it'll be dimethyl. They're on the same carbon. Even though they're on the same carbon, when you have di, you need 2 numbers, and that's why it's 2,2-dimethyl hexine. All right, now the only common name, and actually this was worded incorrectly, I should have taken out the term IUPAC, and the test would be draw the condensed structures for the following names of molecules. Acetylene is the only common name I'm asking you to learn for test number 1. And it's as simple as alkyne. And let's do one of these. B, C, or D. Anybody have a favorite? D, maybe? Okay. And the question is, what's the structure for the following? How do you do that? You start at the right, go this way, Y on the ending, triple bond. If that were A on the, no name, 9 carbons. 1, 2, 3, 4, 5, plus 4 more is 9. Where's the triple bond between carbon 2 and 3? It starts at 2. If this is 1, 2, 3, this is 4, this is 5. On carbon 5 is a methyl group. And on carbon 4 is an isopropyl group. And I actually made a mistake there. It really should be 5-methyl-4-isopropyl instead of the way I did it. But once in a while, even Dr. White makes mistakes. Just don't tell the IUPAC, please. And here on the structure, I didn't make a mistake. You have an isopropyl group. How do you know isopropyl? 3 carbons, center carbon is bonded to the chain. The other type of question on test number 1, reactions. Let's look at either A or B. Oh, let's do B because that's A. That's scary. No, it's not. You look at this and say, what's different? Triple bond. What are we reacting with? By the way, the dreaded catalyst virus attacked this part of the answer sheet, so put down platinum, and this one nickel. Anyway, triple bond. Excess hydrogen, that's what this means, which means you have all the hydrogen in the world that will react with anything hydrogen will react with. Triple bond, excess hydrogen, catalyst. Break the 2 pi bonds, each carbon gets 2 hydrogens. Do you break carbon-carbon single bonds? Nope. Therefore, I have 1, 2, 3, 4, 5, 6 across, 2, 4, 6 across. I have my 2 methyl groups, which are 2 carbons of the triple bond. This right here, they each get 2 hydrogens. And you could have written that CH2, CH2, or the way I have it. If we continue on to C and D, and if we look at this, let's do C, unless somebody wants me to do D. They're both the same. What's different? Triple bond, reacting with excess halogen. Halogen can be chlorine, bromine, fluorine, or iodine. You break each pi bond, each carbon of the triple bond gets 2 halogens. And therefore, you get this molecule. Do I break carbon-carbon single bonds? No. 1, 2, 3. Here are my 2 carbons of the triple bond. Each one gets 2 bromines. And with that, wow, talk about good timing. I shall see those of you, we have lab in a couple minutes.